Welcome to clickmyproject.com. Now let we discuss about objective quality assessment of tone mapped images. Here we propose the method in the tone mapping. Initially we generate the HDR image. The three low exposure, mid exposure and high exposure images are subject to the HDR image generation. Making use of the given exposure level for a dataset, it generates the HDR image. This HDR image is stored in the HDR format. The generated HDR image will be the input to the tone map images quality index algorithm. The tone map image quality index is an objective quality assessment algorithm for tone mapped images. It containing a multi-scale signal fidelity measure based on a modified structure similarity index and a naturalness measure based on intensity statistics of natural images. It converts a high dynamic range to low dynamic range images. It will generate the multi-scale structural fidelity measure. Then we compute the Laplacian pyramid for exposure images. Finally, we fuse the structural fidelity and a Laplacian pyramid image. It generates the tone map images. This is the flow of our project. Here we have to provide our input image. The input images contain the three exposure images such as low exposure, mid exposure and high exposure. This exposure image is passed to the for generating HDR image. Making use of the given exposure level for a dataset, it generates a HDR image. This HDR image is stored in the HDR format. The generated HDR image is passed to the tone map quality index. This algorithm is an objective quality assessment algorithm for tone mapped images. It containing a multi-scale signal fidelity measure based on a modified structural similarity index and a naturalness measure based on intensity statistics of natural images. It converts the high dynamic range to low dynamic range images. The generated tone mapped quality index is passed to the Laplacian pyramid. It is a technique used in an image processing, especially in texture synthesis. The technique involves creating a series of images which are weighted down using a Laplacian transform and scaled down. When this technique is used multiple times, it creates a stack of successive smaller images with each pixel containing a local average. The generated tone mapped quality index and the Laplacian pyramid is passed to the adaptive fusion. Here the generated image is fused here, and finally after the fusion here we are finally getting the tone mapped images. The generated tone mapped image is passed to the analysis part. In analysis here we are computing the MSE and PSNR value. MSE stands for mean square error and PSE stands for peak signal noise ratio. Now let's see the execution part. Here I am having tonemain.m file. This is the main file. Select this file, right click, run the file. This is our guide design. Here we have to provide a 3 exposure such as low, middle and high exposure. Here I am having 4 dataset image, that is church, house and outdoor, and finally tower image. Now I am providing the church image as the input. This is the low exposure that is displayed in the first axis. This is the middle exposure that is displayed in the second axis. This is the high exposure that is displayed in the third axis. These three provided input images passed to the HDR image generation. It will generate the HDR image in the format of HDR. Now the HDR image is generated. The generated HDR image is passed to the image quality index. The image quality is the combination of structure similarity, structure fidelity measurement and the naturalness statistics. Now let's see the result of image quality index. This is the tone mapped image quality index image at the different levels. Now let's see the result of Laplacian pyramid. Here we are finding the Laplacian pyramid for the 3 exposure images. This is the Laplacian pyramid for high exposure at the different levels. This is the middle exposure Laplacian pyramid result. This is the low exposure Laplacian pyramid result. The generated result is passed to the tone mapping. Here we are passing the image quality index with the Laplacian pyramid result is passed to the tone mapping. Here we are fusing the two result. Finally we are generating the tone mapped images. The tone mapped images visible to the fourth axis. Here the result is displayed in the fourth axis. This is the tone mapped images. The generated tone map images passed to the analysis. In analysis, here we are computing the cumulative histogram of tone mapped images. The histogram show the variation between the pixel variance in the generated tone map with the original input image. This is the tone map cumulative histogram of tone map image. This is the cumulative histogram of middle exposure image. This is the histogram value for the low exposure image. And also here we are computing the PSNR MSE value that is displayed in the command window. Here we are showing the result for the objective quality assessment of tone mapped images. Now it provides the better result in the tone mapping. Thank you.